Now, what is the meaning of double-headed arrow? What is the definition of localized and delocalized? Now, this is known as delocalized because this pi bond in resonance means delocalization of. Now, this oxygen contribute 50%. This means the contribution in hybrid will be the -half. These two resonating structure will contribute to form resonance hybrid. We cannot accept electron externally or we cannot donate electron. This is an intramolecular process. Resonating structure does not exist. You cannot change position of atoms. Why we cannot change? Negative charge and this is carbon and they are not resonating structures. If we move this pi bond from this to this position, means if all benzene is planar, all carbon are sp2 hybridized and p orbital is perpendicular to the sp2 carbon. Hello to everyone. Now today we are going to discuss the second effect in GOC. We already discussed what is inductive effect, what is electromagnetic effect, and today we are discussing most important topic of GOC, and that is the resonance. So first of all, you should write down today's heading, and today heading is resonance. Now before starting resonance, we should know some basics. We are using two types of arrow in resonance. Mainly these arrows are developed by fish hook. There is a book named as fish hook arrow. Means he explained different type of arrow which are going to be used in the chemistry. Now these two arrows, what is the difference between these two arrows? The first arrow represent movement of two electron. It is known as double-headed arrow. These two represent double-headed arrow, and this is known as single-headed arrow. This represents single-headed arrow. Now what is the meaning of double-headed arrow? Movement of two electron. Two electron movement from tail to head. These two electrons will move from tail to head is known as double-headed arrow. And if there is a movement of single electron, then it is known as single-headed arrow. This means only one electron is moving from tail to head. So they are simple convention to represent the movement of electron. Two electron movement, tail to head. One electron movement, tail to head. Got it? So write down these two arrows, double-headed arrow and single-headed arrow. Now, what is the definition of localized and delocalized? We commonly use the term local. Local means it is nearer to each other, nearer to us. Similarly, there are electrons which are localized and delocalized. Localized means these electrons are not moving anyway, they are fixed. They are across these two carbon only, means they are fixed. Means these pi electron is carried by two electron only. This pi bond is known as localized. Similarly, this lone pair is localized because this lone pair is carried by one atom oxygen only. So if pi bond is fixed in between two carbon or lone pair is carried by only one atom, then it is known as localized. Now this is known as delocalized because this pi bond is moving across 1, 2 to 2, 3, 3, 4 is moving across 4, 5. Similarly, 5, 6 is moving across 6, 1. This pi bond move across different carbon, therefore they are known as localized. Now this lone pair is moved from oxygen to carbon. Let us assume these electrons move and shift toward carbon. Now this is known as delocalized. What is the meaning of delocalized? Delocalized means this negative charge carried by more than one atom. In this case, this negative carried by oxygen and this is carried by carbon, therefore it is known as delocalized. Now this is localized, carried by one atom. This is delocalized, carried by more than one atom, maybe 2, maybe 3, maybe 4. Got it? So write down this difference between localized and delocalized. Localized means electrons are fixed. Delocalized means shared by other atoms also. Now let us start with a basic example of ozone. This is our ozone and this oxygen has positive charge, this is negative charge. Now in resonance means delocalization of lone pair and pi electron. And what is delocalized? Means movement of electron from one atom to another atom. In this case, delocalization of lone pair takes place. I have to draw this lone pair convert into pi bond and this pi bond convert into lone pair. This is resonance because lone pair is delocalized. Now this lone pair convert into pi bond. So what you have to do? you have to start the arrow from lone pair and drop the arrow in between the sigma bond, center of the bond. Center of the bond means it converted into pi bond. Similarly, when you are converting pi bond into lone pair, what you have to do? You have to start the arrow from the center of the pi bond and drop at oxygen. This means pi bond convert into oxygen. Got it? Now, this pi bond will form here and this will convert into negative. So, we can say that this negative charge is delocalized. Why delocalized? Because this negative charge is carried by oxygen, this at oxygen as well as this oxygen. Got it? Now, these two are known as resonating structures and they are sometimes also known as canonical structures. Resonating structure or canonical structures. Canonical. Okay. Now, these two are resonating canonical structures. Sometimes they are also known as unperturbed structures. Now, these two contribute to form resonance hybrid. Now, how to draw hybrid? Now, there is a sigma bond, there is a pi bond. Therefore, in hybrid, there is a double bond character. Dot, dot, dot represent double bond character. Similarly, across this bond, there is a single bond. This is double bond. This means there will be a double bond character. Now, the contribution of these two resonating structure contribute to form resonance hybrid. Since they are of same stability, therefore their contribution will be 50%. Now, this oxygen contribute 50%. This means the contribution in hybrid will be the minus half. The same oxygen is neutral here. Contribution is 50%, zero contribution toward charge. So, what is the charge on hybrid on this oxygen? There will be a minus half charge and there will be a minus half charge. You got it? This minus 1 charge is equally delocalized among two oxygen. Therefore, we will write minus half and minus half. And this resonance hybrid is the real molecule. This will exist and these are the hypothetical. These structure contribute to form real molecule resonance hybrid. Now, let us consider one more famous example of benzene. RS means resonating structure and RS means resonance hybrid. And this is arrow represent resonance. Now, this pi bond will move here. This means there is a delocalization of pi electron. It is known as resonance. Now, after movement of this pi electron, we will get this second resonating structure. Now, what happened? These two resonating structure will contribute to form resonance hybrid. This is our resonance hybrid. What is the meaning of circle? Circle represent the pi bond can in between any carbon-carbon sigma bond. They are not fixed. They can be found in between any carbon-carbon bond. Got it? So, these are resonating structure. This is the resonance hybrid. In this case, the resonating structure is neutral. Therefore, hybrid will be the neutral. Now, again come back to the ozone. So, first of all, you draw ozone. There are some more features there. This process is intramolecular. We cannot accept electron externally or we cannot donate electron. This is an intramolecular process. जैसे बोलते हैं ना घर की बात है, घर की बात है. It is an intramolecular process, घर की बात है. So negative charge will delocalize and this is resonating structure. They will contribute to form resonance hybrid. More the stable RS resonating structure, more is the contribution in the hybrid. Got it? So first of all, draw this. Now draw this. Now write characteristic. What is the first resonance? What is the meaning of resonance? Resonance means delocalization of lone pair and pi electron. Resonance involves delocalization of lone pair and pi electron. Means we cannot move sigma bond, we cannot move structure of atoms. And we already explained that resonance is an intramolecular process. Because you can move lone pair and pi electron. Basically in resonance, you have to move lone pair and pi electron and within a molecule. Therefore, it is an intramolecular process. Now, resonance hybrid is the real molecule. It will exist and resonating structures are imaginary. Got it? Write down these characteristics. Now, what is the effect of temperature and pressure on resonating structures? There is no effect of temperature and pressure on resonating structure because it is an imaginary structure. The resonating structure does not exist. Something that does not exist, it means the concept of equilibrium, the concept of thermodynamics are not applicable. This means no effect of temperature and pressure on resonating structure because it is an imaginary. Just like a ghost, bhoot. No effect of temperature pressure on bhoot. Now resonance hybrid is formally contribution by resonating structure. How hybrid is constructed? Hybrid is found by contribution of resonating structures. And what is the percentage of contribution? It depends upon the stability. More stable, more contribution. Now next is more the stable resonating structures, more will be the contribution in resonance hybrid. You have to write all these characteristics in your class, in your notebook. Now, what is resonance? Resonance means delocalization of lone pair and pi electron. Now, explain me why this is not a resonance. Because in resonance, we cannot change position of atoms. This is the highlighted term. Atoms remain constant. Atom remain constant means position of atom remain constant. You cannot change position of atoms. Why we cannot change? Because if we are changing position of atom, this means we are doing isomerism. It is not a resonance. Then what we can change in resonance? We can move lone pair and pi electrons only. Got it? This is isomerism. This is not a resonance. Similarly, in this example, this hydrogen is moving from this carbon to oxygen. This means it is not a resonance. It is a isomerism. And it is a structural isomerism. Change in position of structure means they are structural isomerism. So what is the relation between these two? These two are structural isomerism. Or we can say they are keto-enol tautomerism, the type of structural isomerism. We can say they are functional isomers. Because functional isomer are, we already explained in tautomerism, they are known as tautomerism, this is also known as functional isomerism. Or we will study later on structural isomerism. So write down this point. We cannot change position of atoms. Now next point. This is carbon ion, negative charge, and this is carbon ion. They are not resonating structures. Now we can explain by two different ways why they are not resonating structures. First of all, if you calculate sigma and pi bond, so there is a 1, 2, 3, 4, 5, 6, 7 sigma and 1 pi bond, 7 sigma, 1 pi and 1 lone pair. This means 18 electron, and there are 1, 2, 3, 4, 5, 6, 7, 7 into 2 and 6, 20 electrons. Sigma plus lone pair 20 electrons means number of electron must be constant in different resonating structure. Now how this 18 converted into 20? This means the first one is accepting 2 electron. If I donate 2 electron, this means this is an external addition of electron, and we already explained resonance is a intramolecular process, means ghar ki baat hai. Got it? It is an intramolecular process. You cannot accept electron from outside, or you cannot donate electron to outside. Number of electron must remain constant in different resonating structure. Apart from this, there is one more flaw is there. The net charge on this resonating structure is -1, and net charge on this resonating structure is -3. Since it is an intramolecular process, this means charge must be conserved in different resonating structures. In this case, charge is not conserved because of -1 and -3 charge. Got it? So you have to write two more points. Charge must be conserved in different resonating structures. And next, total number of electron must remain same. Got it? Total number of electron must remain same in different resonating structures. One more point is there. These two are not resonating structures. Why they are not resonating structures? What is the meaning of that dot? Dot means free radical, and they are not resonating structures. In first one, UP, what is the meaning of UP? UP doesn't means here Uttar Pradesh, it means unpaired electrons. Unpaired electrons. How many unpaired electrons? 1. And how many unpaired electrons? 3. So there is a condition in resonance. UP must constant. UP must constant means unpaired electron must remain constant. In this case, unpaired electron is 1. In this case, unpaired electron is 3. This means they are not resonating structures. So just you have to add one more point. UP must be constant. Means unpaired electron must remain same in different RS. Although we will discuss this point in our next lecture, so let me explain one more point is there. The atom participating in resonance must lie in same plane. The atoms must lie in same plane. Now, why atoms must lie in same plane? Now, first of all, I will explain you just resonance in carbocation. In order to delocalize this positive charge, if we move this pi bond from this to this position, means if pi bond move from 1, 2 to 2, 3 position, then this carbon become electron deficient. This means there is a positive charge on this carbon. If we move pi bond from 1, 2 to 2, 3 position, there is a positive charge on first carbon. Got it? Now, in order to resonance, this resonance, there is a vacant p orbital, and since there is a pi bond, this means there is a filled p orbital. Now, how resonance takes place? If we move this pi bond from this to this position, then there is a new pi bond will form in between these two. In order to form new pi bond, all p orbital must be parallel. Now, I can write this same statement in different way. In order to undergo resonance, all p orbital must be in same plane, or p orbital must be parallel. P orbital, when will be the p orbital will be parallel? They will be parallel when atoms is planar. For planar means they must be sp2 hybridized or sp hybridized. Now, what happen in case of sp2 hybridized? All atom lie in same plane. The p orbital and sp2 hybridized are perpendicular to each other. Now, in this case, all these are sp2 hybridized. This means all carbon will lie in same plane, and their p orbital is perpendicular to the sp2 hybridized. If all these atoms lie in same plane, then their p orbital will be parallel, because all p orbital are perpendicular to the sp2 carbon. This is our first p orbital, then there is a second p orbital, then there is a third p orbital, or we can explain like that. These are p orbitals. This is pi bond, this is vacant orbital. In order to form pi bond, what will happen? This p orbital will form pi bond. Now, this become vacant. Now, this resonance takes place when all p orbital are parallel. Let us assume if this is perpendicular, if this p orbital is perpendicular, then pi bond formation doesn't take place. So, in order to form pi bond, p orbital is parallel. This means valency atoms must be lie in same plane. Why participating atom? Because resonance takes place across 3 carbon. Across 4th carbon, this is not participating in resonance. This atom may be out of plane. The atoms participating in resonance must lie in same plane, or p orbital must be parallel. Or we can write, in order to undergo resonance, p orbital must be parallel. Both statements are same. And what is the meaning of planar? Planar means sp2 or sp hybridized. Now, let me explain famous example of benzene. What is the hybridization of carbon in benzene? All carbon are sp2 hybridized. Now, since they all are sp2 hybridized, the p orbital is perpendicular to the benzene ring. Got it? If all benzene is planar, all carbon are sp2 hybridized, and p orbital is perpendicular to the sp2 carbon. Got it? So, we have 6 p orbital which are parallel, and there is a pi bond, alternate pi bond. If I move this pi bond from this to this, this new pi bond will be formed. This is known as resonance. Now, why this resonance takes place? Because all p orbital are parallel. Means the atoms participating in resonance must lie in same plane. Plane means sp2 or sp hybridized. Now, let us assume if this pi bond is perpendicular to this pi bond, then there will be a no resonance. Got it? Suppose, let us take this type of example. Let us assume there is a pi bond and there is a pi bond. Let us consider this example. Now, in this case, there will be a no resonance. We cannot move this pi bond because this p orbital and this p orbital are perpendicular to each other. In order to undergo resonance, pi bond and pi bond must be parallel. If they are parallel, then there will be a resonance. If they are perpendicular, then there will be a no resonance. Got it? So today I explain you what is the definition of resonance, what are the conditions of resonance. Now, upcoming 4 to 5 lecture, we will first of all, we will learn how to draw resonating structures and when will resonance takes place. When will resonance takes place, then how to draw resonating structure, and the last part will be how to compare stability of resonating structures. So that's all for today. Keep learning. We will meet again. Thank you. Bye. Take care.